All right, I just want to talk a little bit about statistical significance and what it is and what it means. First of all, the idea behind statistical significance, what we're trying to do is find out whether a result is due to chance. And when I say chance in statistics, I mean random sampling error. Is what we observe in our sample data just due to the luck of the draw, who we got in our sample, or random sampling error? Or is what we observe in our sample representing something really going on in the population? That's why we test statistical significance. And usually we have some sort of null hypothesis. This would be for an independent samples t-test. The null hypothesis is that the population means are equal. There's nothing going on between them, they're equal. And the alternative might be that the population mean for the first group is bigger than the population mean for the second group. Might be the population mean for the first group is less than the population mean for the second group. Both of those are directional because we're speculating that one group will be higher or lower than the other. The non-directional alternative hypothesis is that the two means are not equal, but we're not going to speculate ahead of time which mean will be higher. We're just going to speculate that they might be different. These directional alternative hypotheses are lead to one-tailed t-tests, and the non-directional alternative leads to a two-tailed t-test. Most of the time we want to be doing two-tailed t-tests. There's a lot of problems with one-tailed t-tests that I won't get into, but most of the time we want to be doing two-tailed. However, the question that's asked determines whether you've got a one-tailed or a two-tailed alternative hypothesis and t-test. If my two groups are men and women, and I say I want to know whether men spend more money at Christmas time than women on presents, that's a one-tailed hypothesis, so it would be a one-tailed t-test. Alternatively, if I said I want to know whether men and women differ in how much money they spend on Christmas presents, that would be a two-tailed test. So the question determines whether it's a one-tailed or a two-tailed test. Now, when we're doing a test of statistical significance, what we want to know is how likely is it that the result that I got from my sample data was just due to chance? And generally speaking, what we do is we set up a rule ahead of time before we even do the test. And that is, we choose an alpha level. And the one that's typically used in psychology is an alpha level of 0.05. And what that's saying is, if the probability or the likelihood of our results being due to chance is less than 5%, we will conclude that the result was not due to chance and is therefore statistically significant. That's how the alpha level works. Now, if it's very important for you to be right, like life and death situation, being wrong up to 5% of the time might be problematic. You might want to choose an alpha level of 0.01 or 0.001. But if it's not critical, if you can make a mistake every once in a while, like in most cases in psychology, an alpha level of 0.05 is acceptable. Once you choose your alpha level of 0.05, you can find t-values that are likely to occur by chance exactly 5% of the time. And if it's a two-tailed test, there'll be a positive t-value and a negative t-value. And the way that you find those is by looking at Appendix B. This is for a t-test. So if we have, say, two samples, say 16 men and 16 women, the degrees of freedom will be 16 plus 16 minus 2, or 30. And we've got a two-tailed test, 30 degrees of freedom, and an alpha level of 0.05. Then there's a 5% chance there's a 5% chance that we would get the t-value by chance of 2.042 or negative 2.042. So we take that 5%, we divide it 2.5% at the low end of the distribution, 2.5% at the high end of the distribution. And these are our critical t-values. So two-tailed test gives us two critical t-values, one at the negative end, one at the positive end. And what the critical t-values do is they mark the beginnings of the regions of rejection. Anything beyond these critical t-values is going to be in the region of rejection. And then when we calculate our observed t-value, if our observed t-value falls, say, here in the region of rejection, we would reject the null hypothesis. Or if, say, we get an observed t-value, we calculate the difference between the sample means, divide by the standard error, get an observed t-value of, say, -4. That's in the region of rejection also. We would reject the null hypothesis. But if we get an observed t-value of, say, 1.3, that's not in the region of rejection, and we would retain the null hypothesis. So here's what we would say. If we get an observed t-value in the region of rejection, we say our observed t-value exceeds our critical t-value. Therefore, we reject the null hypothesis. We conclude that our results were not due to chance, and the population means differ. There's a significant difference between the population means. If our observed t-value does not fall in the region of rejection, we say our observed t-value does not exceed our critical t-value. Therefore, the probability of our result being due to chance is too likely for us to reject the null hypothesis and conclude that it wasn't. And we retain the null hypothesis, which says there is no significant difference between the population means. That's what statistical significance is all about. If it's statistically significant, you're concluding your result was not due to chance. And what the critical factor here is, we're using sample means, sample data, to reach conclusions about the population means. So when you wrap words around a test of statistical significance, you need to talk about the populations, because that's who we're trying to reach conclusions about. Are the population means different? That's what the test of statistical significance is all about.